I am Jerico Fiestas Flores. Today I'm going to present a dynamic economic analysis of oil sands processed affected water treatment alternatives in Alberta. This is the name of the co-authors we've been working with. If you haven't seen one of these before, let me introduce you to a tailing pond, a facility used to store oil sands processed affected water, or OSPW, a toxic byproduct of the oil sands extraction activities. In Fort McMurray, Alberta, the 438 million cubic meters of OSPW occupy a large area of 220 square kilometers. Thus, as you can imagine, is a large area, and here you can see how they look. The tailing ponds are occupying land that used to be boreal forests. And by government mandate, these areas must be reclaimed when the mining activities end. That is, the disturbed land has to be converted to an ecosystem approximating the initial forests that were there before mining began. However, due to their toxicity, all the OSPW that you can see here cannot be discharged to the Athabasca River without any treatment. While much of this water is recycled, over 80%, enough new water comes in from the river and from the water in the mines themselves to increase the quantity that must be stored each year. This has caused a rapid accumulation of fine tailings and OSPW in northern Alberta for the last 60 years, creating an obstacle to reclamation, which is required by regulation. Although there are different technologies that can be used to treat the OSPW, they are very expensive, and the mining companies and the regulator have yet to decide and agree on which is the most efficient treatment for the water. These treatments must ensure that the quality of the treated OSPW is high enough so they will not adversely affect the Athabasca River. This is why my research aims to analyze current and new technologies that have been successfully tested in the lab and in small control fields trials in order to determine the most cost-effective treatment approach or combination of approaches and the best time in the remaining life of the mines to implement these treatments. To accomplish this, we are analyzing different treatment technologies like ozonation, UV disinfection, pit lakes, and wetlands. Our focus is in understanding the attributes of each technology, like the maximum amount of OSPW each one of them can treat, and how long does it take to get to a desired water quality. By adding the infrastructure needed to scale up the technology and how they complement each other, we will be able to estimate the cost for each treatment. The cost information will be incorporated in a dynamic cost minimization model, which aims to find which approach or combination of approaches have the lowest overall cost over the remaining life of the mine, which is the production period, plus the 10 years period that they have after the mine to complete the reclamation of the mining site, which is the post-production period. For this, we also need to model the oil sands process water cycle, so we know how much new volume of water is created per year and how much will be recycled. Here we can see that each cycle will be different in each production period, in the production period and in the post-production period. The model will also allow us to include different factors like the precipitation and how this adds up to the volume of OSPW and the reduction caused by evaporation. By applying this model, we'll be able to obtain two outcomes. First, it will allow us to identify the most cost-effective treatment technologies that meet appropriate regulatory standards for the river, standards that have not yet been fully decided by the regulator. And secondly, it will help us determine if it's more efficient for the firms to do early treatment of the water during the production period or wait until the post-production period or a combination of both. This information will help the oil sands industry and the Alberta government to implement cost-effective technologies to treat the OSPW and may even help with identifying the best regulatory approach. Thank you very much.